Sizing of pipes and valves. Pipe network is preferred to be designed according to a velocity limitation from 1.5 to 2.3 meter per second. Split lengths for lateral circuits. Where the valve is located in the center of a line of a sprinkler has several advantages over the straight lateral circuits. The total flow for the circuit is split in half, which can often reduce the size of pipe required. In addition, it affects the balance of the pressure losses throughout the network. Normally, a valve should be the same size as the lateral line it serves. We can summarize this that the best irrigation distribution will be through a closed loop basis, which optimize the pipe size. In addition, it have a great benefits on the pressure distribution and the flow balancing. Determining irrigation requirements. To answer this question, how much water has to apply to the plant material and how often and how long does the system need to run? A number of factors need to be studied. The local climate is one of the main factors that influences how much water is needed to maintain good plant growth. The plant water requirement includes the water loss by evaporation into the atmosphere from the soil and by transpiration, which is the amount of water used by the plant. So the combination will be through at a very important term that we need to keep it in our mind, and we will discuss through the calculation which is called the evapotranspiration, and it can be summarized to ET. We start with the indicated relation for calculating the total required water quantity or the total required water volume through 1 day of irrigation through a certain plant. You will find that the relation have the evapotranspiration factor multiplied by crop coefficient by the density by the exposure factor multiplied with the planted area multiplied by a constant factor 0.623. All of this are divided by the irrigation efficiency. Each factor from those factors as the crop coefficient, its range is about from 0.1 to 0.9 and are divided into four main categories. Drip irrigation consumes low values, so it's mainly depending on the type of irrigation. Going for the values like 0.1 can be achieved through using the drip irrigation system. Planting density factor. Its range is about from 0.5 to 1.3, and this range is separated from three main categories: low and average and high. Each one of them are depending on the distribution of the plant itself. While for the exposure factor, the microclimate and exposure factor ranges from 0.5 to 1.4 and divided in three main categories. Average is open field, low moderate wind, part sun. Higher wind and greater exposure take high factor, and a protected or shaded spaces may use low factor. So it's mainly depending on the relation between the plantation and the atmosphere surrounding or the area surrounding the plantation. Is it windy? Is it shady? Is it directly to the sun in open space? All of these factors are affecting the exposure factor itself. If we go for the irrigation efficiency, it's commonly if we go for, as example, the drip irrigation is higher efficiency than the sprinkler irrigation, as the wasted water from the sprinkler is higher than the drip irrigation. So as long as the wasted water is increased, the efficiency of the system decrease. So usage of drip irrigation is very effective and are used commonly for green buildings, and in case you need to have uh, a water saving program that could save the consumption of the daily water wasted through the irrigation. By this relation, you will be able to figure out or calculate the required daily water capacity or the required daily water volume for a certain green area through a certain location with a certain type of plantation density and the irrigation efficiency, or by using a certain type of irrigation, its efficiency will reflect this equation. If we have an example for more clarification for the indicated equation, let's say we have a 1,500 square feet of grass lawn. And by starting with the ETO using zero point 0.3 inches per day, depending on June month or August month, so that means that we are going to follow the hottest months in the year to have actual rates of consumption through the summer time. Now let's use the previous relation using the zero point 0.3 multiplied by the grass value multiplied by the area multiply the constant factor of 0.62 divided by the efficiency, and let's say the efficiency of the sprinkler systems is 0.75. As we said that if we are going to use a drip irrigation system, you will have higher efficiency. So this relation will calculate a certain gallons of water per day. You will see here that the required gallons per day or the required water capacity per day for this 1,500 square feet of grass lawn will be 372 gallons per day.